yelling at you. All right, Aiden is looking out the window and spots a Precal book on the ground below. So here he is in the building. Here he is, there's Aiden, looking out the window. Down here's the book on the ground. The window is 32 feet above the ground, and the book is 119 feet from the base of the building. That's it. That's the picture. Now what do I want to know? The angle of depression. And we agreed that technically the angle of depression is up here, but it's always equal to the angle of elevation, so we're always just going to put it there. Every angle is going to go there. So then I stand back and I say, okay, I have to use a function, sine, cosine, or tangent, to describe this. Which function will I use given the stuff that's involved in the problem? Tangent. That's a tangent problem, opposite and adjacent. So tan x equals 32 over 119, right? Now, I got to type this into my calculator, and I'm finding an angle. So remember, when you are finding an angle, you must use your second tangent button. So second tangent, 32 over 119. So I will second tangent 32 divided by 119. And I got 15.05 degrees. So the answer to the problem is 15.05 degrees. Okay? Gould? Number 1. A car with 14-inch wheels is traveling at a speed of 67.5 miles per hour. So 67.5 miles per hour. I always have to have some number to start with. So in this case, that's what I have to start with. And I ultimately want to end up with revolutions per minute. RPMs, revolutions per minute. So I somehow have to get from miles and hours into revolutions and minutes. Well, the minutes is easy. We know that there are 60, we know that, but I need that at the bottom. We know 1 hour is 60 minutes, and I knew I had it upside down because I need these to cancel, right? And I want my minutes in the bottom. So that part's done. So now I have to get from a distance to a revolution. So that's when I have to remember that 1 revolution is a circumference. And a circumference is 2 pi r. And in this case, r is 14 inches. So 28 pi inches is 1 revolution. A revolution is a circumference. Circumference is 2 pi r. R is 14 inches. So I know that 1 revolution is 28 pi inches.
So is the radius 14 inches or is it 7?
Oh, the radius, that I meant to say, I didn't, did I? And I meant to say radius. So if you had, let's see, what would that be? If you had half of the right answer, I'll give you your points back. Okay? Because that's what will happen. I meant to say 14-inch radius, but I didn't put that word in there. So yes, that means radius, but I didn't say that. So, okay. So if check your answer with mine. If you get exactly half, I'll give you your points back. So I'll need to collect your quiz again. Okay, so now I'm down to, I got my revolutions per minute, all that's good, but I still have miles and inches floating around. So I remember that 12 inches is 1 foot, and 5,280 feet is 1 mile. So now the miles will cancel, and the inches will cancel, and the feet will cancel, and all I have left is exactly what I wanted. So I type in everything on the top. So 67.5 times 12 times 5,280. And then I divide that by both of these. So if you're going to divide them by both, you need parentheses. So I'll divide by 60 times 28 pi. And I got 810.33 revolutions per minute. So if you got half that, if you have 405.16, I want you to turn your paper back in so that I can give you your points back, okay? Now we'll do one more. Thank you, Audrey. There's that, honey. Let me know if you have any questions. Okay. Okay, I'll do one more. So if you have that, you need to turn your paper back in. Okay, read. Last one.
Number 5.
Number 5 says find the arc length. Yeah. So arc length, remember, is what? Radius times radians. Okay, let's look at our problem. What do we have? We have a radius of 10 inches, and we have an angle of 1.8 radians. Arc length is radius times radians. So the answer is 18 inches. Radius times radians. So that's all there is to it. Unit will match the radius. Okay, so put those away. We got stuff to do. Moving on. Maybe when you do your group chats, you can start group chatting about your questions you have in math. Go over those with each other. Okay. Yesterday, we started a conversation about the graphs. And we need to continue that conversation. So, let me find my notes here. We are ready for H, I believe. So, we did this yesterday. We shouldn't have a whole lot of problems with this. Let's solidify what we know here. We're going to sketch this. It is a sine curve. So we know what a sine curve looks like. So that's a sine curve. So that's the shape I'm going to have. But there's a couple of things that have changed. First of all, what does that negative do? Upside down. So it's going to be valley and then hill. What does that do? To the right. So I have an upside down sine curve that starts here and ends somewhere. So I have this, right? I know that its amplitude or its height is 2. So I can go ahead and label that because this is my vertical stretch. Now, in order to do all of the labeling, I need to know I need to know how long it is. What's the period of this thing? So in order to do that, I have to remember what is the period of a normal sine. Just a regular old run-of-the-mill sine. The period is always 2 pi. Very good. You were listening. Good. 2 pi. But I've changed it because of this number right here, right? And what does that number do? It divides the period. So 2 pi divided by 1/3 is 6 pi, right? So that means that from start to finish is going to be 6 pi. So what does that make this? No, we didn't make that 6 pi. It makes it, you could think of it as like 6 1/7 pi, because it started at 1/7. But I don't like these mixed numbers, so I'm going to think of that as 4243 over pi. I mean 43 pi over 7. Remember, it had a head start. So it started at a 7th and traveled 6. So that's a 7th and 42 sevenths. So it ends at 43 sevenths. Now what's the middle point? All these points are important. We have to label all of them. What's the middle one? Well, 1 and 43. 22. Because 1 and 43 is 44, and half of 44 is 22. And that's how we find midpoint. We average. We add them and divide by 2. That's how you find the middle value. So now I need to find the middle value here. Well, that's 1 and 22. So when I add those, I get 23 sevenths. Well, I can't cut 23 in half evenly, so instead of dividing by 2, I'm going to multiply it by a half, and this is 23 pi over 14. When you find the midpoint, you add them and divide by 2. You don't mix decimals and fractions, so you add them and multiply by a half. So 23 sevenths times a half. Same thing here. When I add them, when I add them, I get 65 sevenths, 22 and 43. Is that right? Yeah. I need half of that, so it's 65 fourteenths. Okay, so you start with your shape. Make sure you have it going in the right direction. And then you do your label. All right, let's try the next one. It is a cosine. So I have to remember my cosine shape. So y equals 2/3 cosine 2/3 x plus pi over 6. Okay. What's that tell me? Where I start, right? And I'm going to start at negative pi over 6. And it's a cosine, and it's positive, so would you agree that I have a shape that looks like this? Starts at the top of the hill, ends at the top of the hill. And your divisions, we're not ready to find them yet, but those will be your divisions. Where it crosses, the x-intercepts, and where it minimizes. My height is going to be 2/3. My amplitude. And now I need my period, because the only way to figure out where it ends is to know how long it is. What's the period of cosine? 2 pi normally. But we are dividing by 2/3, this 2/3, which is 2 pi times 3/2. So that means that distance from beginning to end is 3 pi. So I got to start here, and I got to travel 3 pi. So I'm starting at negative a 6, and I'm going forward 3.
So the where it ends is 3 pi, and then Oh, the period's 3
The
pi?
distance is 3 pi.
And then where it ends is when we add the
Now,
distance.
I'm figuring out where it ends right now.
Okay.
Pretend you're a little guy standing on the number line. This is a number line. And if you are backed up -1/6, and they tell you to take 3 steps forward, you're not going to end up at 3 because you were backed up when you started, right?
Yeah.
So we're figuring out where you're going to end up.
Okay. Thanks.
17.6.
Oh, I'm not there yet, but yes, I think that's right. -1/6 plus 18/6. So that'll be 17/6 is where we end up. Read.
So there's always going to be 4 marks on the like
Yep.
positive side.
The quadrants. Yep, the curves come right from the quadrants. Every quadrant is graphed. Okay. Now I need the midpoint, which for the cosine is the valley there. So -1 and 17 is 16, and half of that is 8. That one's easy. And remember, you don't need to reduce. It's fine to leave it unreduced. If you want to reduce it, great, but you don't have to. Okay? Now, -1 and 8 makes 7, and I need half of that. So that's going to be 7/12. 7 doesn't divide by 2, so I need to do times a half, and I get 7/12. All these have pi's on them. I'm just not saying the pi part. 8 and 17 make 25, which doesn't divide by 2. So I'll multiply by a half, and I get 25 pi over 12. And there is a picture of your curve. So if you have to list information about it, which you often do, you'll say the amplitude is 2/3, the period is 3 pi, the phase shift, P-H-A-S-E, phase shift is -pi/6. It's also called horizontal shift. And we could have a vertical shift in our problem, but we don't. The only way we would have a vertical shift is if we had like a +1 on the end, and that would take that picture and move it up 1. Okay? Now, we're going to do something really exciting. Take a look at part 2 now. I have drawn the picture, and you are going to give me the equation. Now, notice it says you have to do both a sine and a cosine equation. And here's why, kids. We talked about this yesterday, but in case you missed it. We have this curve that looks like this, but technically it goes on forever and ever, right? I only drew a piece of it, but technically it goes on and on. Now, the piece that I drew looks very much like a sine curve. Would you agree? So let's write that equation first. We're going to write a sine equation. Now remember, look at the equations we just did. They have a number in front, then they have their sign, then they have a number, and then they have their parentheses with the x. And then potentially they could have another number if we had a vertical shift, but we don't have one. But there could be one in some kind of situation. Okay, so your job is to fill in those numbers. Now, I think this one is super simple. If you're looking at that as a sine curve, then it's starting right here. So your shift is pi over 6. So this would be x minus pi over 6. Easy, easy, easy. I also think this is super simple because you can tell by the label on the picture that the amplitude is 1/5. So this is a 1/5. Now the only thing you do have to be careful about is sometimes the picture could be upside down, and then you'd have to make that a negative 1/5. But this picture is right side up, so it's all good. Okay, this is the tricky one for people. Let me for a minute just call that number n. Now that number changes the period, right? And we know that if we take 2 pi, always with a sign, we start with 2 pi, and we divide it by that number, we get our period. That's how it works. Would you agree? That's how we've been doing it? Well, do we know our period, guys? Do we know what our period is in this problem? We absolutely do. It goes from 1/6 to 5/6, which is what? 4/6. So your period, so 2 pi over n is 4 pi over 6. That's our period. So we can cross multiply. By the way, you could reduce that if you wanted to. That does reduce, but I'll leave it unreduced. So 12 pi equals 4 pi n. So I'll divide by 4 pi. And what is n? What is the number that's going to go in front of that parentheses? 3. Not 3 pi. The pi's cancel. Just 3. Just 3. Now, you want the really good news now? You're going to write a cosine equation. The 1/5 is going to stay. The 3 is going to stay. The only thing that changes, if you think about this as a cosine, amplitude doesn't change, period doesn't change. The only thing that changes is where do you start it? Because if it's a cosine, wouldn't you want to start it up here? Then you're looking at this as your curve. Now I haven't changed any dimensions of the picture, so these two numbers will never change. But this will, because if it's a cosine, that has to be pi over 3. Would you agree with me? Okay? Now there's one more there. I want you to take a look at that one. And I want you to take a minute and get started on it, because I almost forgot in all my ranting and raving. I almost forgot that I made our brownies for our wrestling people. So I'll bring these around. You have a napkin and brownie if you want one. If you don't want one, that's fine. Just say no like you always do. What, you're going to take one? Am I guilty to it? Thank you. All right. Now, while I'm doing this, you're working on your graph here, folks. You're writing your equation for the second problem. You gonna have one today, Michael? equation. This one, when you looked at it, did you start with it as a cosine? I think it's easier just to start with what you see when you look at it. It doesn't make any difference, but it looks like a cosine the way I graphed it. So I know my equation is going to have something in the front, cosine, something, parentheses, something. All right, I can tell, I think that's a 6 in front there. And I can tell that my phase shift is negative pi over 9. So did you do this? You at least got that part. Now we got to work on this number. And whatever it is, we know 2 pi divided by it gives me my period. So I have to look at my picture. My period is going from negative 1/9 to 16/9. I mean 15/9, I'm sorry, 15/9, negative 1/9 to 15/9, which means that my period is 16/9. Would you agree with that? From negative 1 to 15. Here's negative 1, here's 0, here's 15. How far is it from negative 1 to 15?
Okay, yeah.
Yeah, I'm not adding them. I'm not averaging them. I am finding how far apart they are.
So, does it matter if it's negative?
If what's negative?
Like the negative 1?
Yes, because that means I have 1 step to get to 0, and then I have 15 more steps to get to here.
But you would technically like add 1 because it's like
You're finding distance, so you're subtracting.
Okay.
15 minus negative 1. That's how we find distance.
Oh, okay.
Or we draw it on the number line and just count. If it were positive 1, then it would only be 14.
Right, okay.
Okay, so 18 pi equals 16 pi n. So n equals 18 pi over 16 pi. Pi's cancel, and that reduces to what? 9/8. So this number is 9/8. Now, if you want to think about that, because now you need a sine curve, I would want to. One possibility is starting my sine curve at pi over 3. Can I look at this as a sine curve? However, it's upside down. So when I write my equation for my sine curve, remember, most of it doesn't change. But I will have to include a negative. So negative 6 sine, 9/8. Now, I'm starting at positive pi over 3. So this is going to be minus pi over 3. And that will be my sine equation. Okay? Now, we've got more the same, but now notice I stuck a number on the end. So that means we're going to do everything we just did. And then at the very end, we're going to take whatever we've got and pick it up. Do that at the very end, though, okay? So let's do what we've done. And get this first one sketched. So here we go, negative 2 sine 3x plus pi over 6 plus 1. All right, let's start. Negative pi over 6. Now it's negative, so it's a sine curve, and it's going to look like this. Would you agree with that? So far, so good? Now, I need to know where it ends. So I'm going to find my period. So my period is 2 pi divided by 3. Which, just for the fun of it, since that's a 6, I'm going to think of this as 4 pi over 6. Would that be okay with you? If I thought of my period as 4 pi over 6? That will make it easier to find my endpoint, because how do I find my endpoint? I take whatever my beginning is, and I add my period to it. So, since I made that 4, 6, this is going to be 3, 6. Everybody okay with that? And then this will be the halfway point. So -1 plus 3, I'm doing midpoint. -1 plus 3 is 2, and half of that's 1. Read. Okay, the period is 2 pi divided by this number, and 2 over 3 is the same as 4 over 6. I just wrote it with a 6 because I knew I was going to be adding it to here. Now, -1 and +1 is going to make 0. So this is actually the low point of the graph right there. And 1 and 3 makes 4, and half of that is 2. So there is a picture of everything but this. Would you agree with that? Now, that tells me to move everything up 1. Now, remember, the amplitude was 2 to start with. So we're actually, our low point is at -2, and our high point is at +2. So when I add 1 to that, it's going to make my low point at -1 and my high point at 3. Would everybody agree? It's also going to take these points, which are the other important points of the graph, the zeros, the x-intercepts, and it's going to move them up 1 step. So instead of them all being at 0, now they're going to be at 1. So I'll just connect the dots with a nice smooth curve, and there it is. Easy. Now let's fill in all that information because I haven't talked about all of it yet, so I'll make sure we do. Period, we did. Here's your period. 2 pi over 3. You do not need to reduce in your labeling, but please reduce in your answers over here. Amplitude, what's our amplitude? +2. Remember, we never ever can have negative amplitude or negative period. They are distances, they're positive. The negative is important because it turns your picture upside down, but it does not change the amplitude. The amplitude is 2. Also, does picking up the curve change the amplitude? No. The height of the waves, aren't they still up 2 and down 2? Yeah. All right, phase shift. Phase shift is -pi over 6, or if you prefer, left pi over 6. You can use the word left. Vertical shift, 1, or if you prefer, up 1. Negatives are left and down. Positives are right and up. So that's a negative, this is a positive. Frequency. Frequency is the reciprocal of the period. The reciprocal of the period. So my period is 2 pi over 3. So the frequency is 3 over 2 pi. Now notice, when I wrote that, I was very careful to make sure that bar was long enough to get the pi underneath. Because if you give me one of these, that's wrong. that is 3 pi over 2, and that isn't what I mean, right? So make sure when you flip your period that the pi is clearly in the bottom. Now, you're saying to yourselves, if you can even think with all that filing going on, what is frequency? Let me show you for a second what frequency is. Because you've heard that word. You've heard the word frequency before. Let me draw a sine curve, a couple of them. Okay. Let me draw these two sine curves for you to look at. Now, if I said to you, what is the period of this, you would tell me the period is 4. I didn't put any pi's in there, I'm just looking at numbers, so the period's 4. If I said, what's the period of this one, you would say 4/8 or 1/2. Now, what I just told you is the frequency is the reciprocal. So the frequency of this curve would be 1/4, and the frequency of this curve would be 2. Now, what does that mean? Frequency is the number of periods that you can draw in 1 unit of length. So if I look at just 1 unit of length in this top picture, how many periods can I draw? Well, I can't even draw a whole period. I can only draw 1/4 of it, so the frequency is 1/4. If I looked at an interval 1 unit long, I'd have to extend my picture, right, to get 1/8. And when I did that, I'd actually have another cycle done. So how many periods can I draw in 1 unit of length? 2. Frequency is the number of cycles, the number of periods in 1 unit of length. These are sound waves, people. So when you dial your radio to a certain frequency, that's what's happening. Those waves are either closer together or farther apart. When you turn up the volume, you're increasing the amplitude, the height of the waves. So the taller the sound wave, the louder it is. The more squished together they are, the pitch is different. And your radio antenna picks up different frequencies. Interesting how it all fits together. Okay, let's get one more done here, and then we'll look at our word problem, and then we will be done with 4/4. All right, so let's graph our cosine. By the way, anyone in physics? You guys talk about that in physics, maybe? All right, here we go. Y equals 1/2 cosine. Okay, tricky problem. What's different about it? Okay, and it can't be there. Okay, it can't. So the first thing we have to do is divide it out. So we have to factor out the 3. The 3 has to be out of the parentheses if we're going to determine the correct phase shift. So I'll pull the 3 out, and that will leave me with x minus what? Pi over 3. Perfect. Factoring is division. When you divide out something, you're factoring it out. And minus 2. So that must be step 1. Okay, so now I got a cosine curve with an amplitude of 1/2. Okay, I'm going to change my scale here a little bit, because you can see what's coming. coming. Okay, so this is a half and 1 and 1 1/2 and 2 and 2 1/2. And negative a half and negative 1 and negative 1 1/2 and negative 2 1/2, or negative 2 and negative 2 1/2. Okay. So my cosine curve starts at pi over 3 and has an amplitude of a half. Now I'm making it squishy, guys, because I'm going to have to drop it down too. That's 2 holes. What's my period? 2 pi over 3. That works out nicely, because if I start at pi over 3 and my period's 2 pi over 3, where's it going to end? 1/3 and 2/3 makes 1 pi, or if you prefer, 3/3, if that's going to make it easier for you to do the midpoints in a minute. Remember, to find your ending point, you just start wherever you start and add your period, right? All right, so what's right in the middle of that? Well, 1 and 3 makes 4, and half of that is 2. 1 and 2 makes 3/3, and half of that is 3/6, or 1/2. Two and 3 makes 5/3, and half of that is 5/6. They're all going to have pi's on them, so don't worry about the pi when you're doing the arithmetic. 2/3 and 3/3, 5/3, times a half, 5/6. All good, except for down 2. So now we'll take this point and bring it down 2, and this point and bring it down 2. Now this one's at negative a half, so it's going to come down to negative 2 1/2. This one's at 1/2 positive, so it's going to come down to negative 1 1/2. Are you following what I'm doing here? Dropping everything down 2. If you were doing it on graph paper, you'd see it more clearly. Anyway, connect the dots with a nice smooth curve, and there it is. There it is. Period, amplitude, phase shift, vertical shift, frequency. Here we go. Already figured our period, 2 pi over 3, which makes our frequency 3 over 2 pi. Amplitude, 1/2. Phase shift, pi over 3, positive, right? And vertical shift, negative 2 down. Is that easy? It's got some tricky components to it, but it's not bad. All right, let's see if we can read number 4 and at least get a start on it, maybe. Oh boy, this is sort of like the ones where I drew a picture for you. You have been told that the period is 12 hours and 24 minutes. y'all been to the ocean? You know the tides come in and go out, and the water gets deeper and shallower. That's periodic. You know, if you measure the water level, it gets deeper, and then it gets less, and then gets deeper again. So you're writing I think we're writing the equation for this. And then we're going to answer some questions. So we are going to have a function that has a period. Instead of doing 12 hours and 24 minutes, what if we made that a decimal? 12.4? How'd I do that? 24 minutes, 24/60ths. So my period is 12.4. Now, I know that high tide happened at 9:36, and I know the depth was 2.7, and then I know that low tide occurred at 3:48, and the water was only 2.1 meters deep. All right, so let's see if we drew a picture of that. Forget labels for a minute, or just randomly I'll say this is 9:36 a.m. and the water is 2.7 deep. And then at 3:48, and again, these are just times, I'm just randomly putting on there, the depth is 2.1. And then would you agree at some point it's going to get back to 2.7? And if I drew it, it might look something like this. And how long is it from here to here? From high tide to high tide would be how long? 12.4. Or, since that's in minutes, it'd be 12 hours and 24 minutes. So the next high tide can be expected 12 hours and 24 minutes after this one. Would you agree with me? So the next high tide, let's see, if I went 12 more hours, oh gosh, what would that be? That'd be, let's see, would that just be 10 o'clock p.m.? Because 12 hours would be 9:36 and another 24 minutes would be 10 o'clock p.m. if this was a.m. All right, so what do I want to know? At what time on the 4th of July did the first low tide occur? Now, we had a low tide at 3:48 p.m., but would there be another low tide back here somewhere potentially? Let me draw better than that. Like that? That picture really is bad. So here's another low tide. When would that have happened? No. Wouldn't it have happened 12 hours and 24 minutes before this one? So 12 hours before would be 3:48 a.m. So I have to go another 24 minutes. So is that 3:24 a.m.? So I had a low tide at 3:24 a.m. and another low tide 12 hours and 24 minutes later. What was the approximate depth of the water at 6 a.m. and at 3 p.m. that day? And what was the first time when the water was 2.4 meters deep? Any idea what we need to do to answer those questions? We need to write the equation of this curve. Because when we get our equation written, it's gonna have a y and an x in it, and we're gonna plug in whatever information they give us, and we'll solve for the other one, okay? So we will work on that next time. Let's gather up, get all your stuff cleaned up. You don't need to spray the desk, but you do need to throw your napkins away, please. You guys need to stay on for the blessing here. And then everybody can head off for higher ground.